Well, hello, calculus students. Hey, what I need to do with you today is I need to cover our Chapter 7, Day 5 material called Riemann sums. What we do today is we continue our studies of finding the area under a curve. What we're really building to is the fundamental theorem of calculus. Today's method is a little tedious, because what we're going to do is you're going to be given some curve, and we're going to be putting rectangles and trapezoids under this curve and adding up those areas. It was discovered in the mid-1800s by a guy named Bernard Riemann. I have a beautiful picture of him on the next slide. Look him up on Wikipedia. There's four methods that I'm going to show you today. There's going to be what we call left-bounded rectangles, right-bounded rectangles, the midpoint method, and the trapezoidal method. The best way to do this is to just jump in at it. So there's Bernard Riemann. Kind of cool that we're still doing today something that was discovered in the mid-1800s. So I kind of think that's neat. So come over to your number one. Picture what we have going on here. I've given you the curve f of x equal the square root of x plus 1. And I blocked off a certain interval called 0 to 2. And what I'd like to do is put four rectangles under that curve. So hence the part that says let n equal 4. Four rectangles. Now I want to point something out. Look at my four rectangles that we have drawn here. Notice that the curve, square root of x plus 1, notice that this touches it on the left point of each of these rectangles. There's where the term left-bounded comes from. If you would, peek over to 1b real fast. Notice that here's the curve, square root of x plus 1. Notice that we drew some rectangles, but notice how the curve hits the right side of those rectangles. So when we say left-bounded, right-bounded, that's what it looks like. The curve touches the left side of the rectangles, the curve touches the right side of the rectangles. Now, so here goes. Just some simple algebra, really no calculus in here. Right now we need to figure out the width of each rectangle. Well, my interval goes from 0 to 2. So I have a width of 2. And I'm going to put four rectangles in there. So 2 divided by 4 is 0.5. Each of these rectangles has a length of 0.5. It also means I'm counting by 0.5s. From 0 to 2, counting by 0.5s. So we're going to put a 0 here, a 0.5 there, a 1, and a 1.5 there. Now, here's what we need to find. To find the area of this first rectangle, I know it's going to be 1/2 times something. Well, I need the height of this rectangle right here. So what I need to do is plug 0 into the original. Square root of 0 plus 1 is 1. The square root of 1 is 1. So I know on rectangle 1 I've got 1/2 times 1. Plus, now let's go get rectangle number 2. Well, I know its length is also 1/2. Now I need the height of it. So I need this height right here. So I need to plug 0.5 in to my original equation. And guys, when I did that earlier, I had 1.71. So I got 1/2 of 1.71. Now let's go get rectangle number 3. So I'm working on this rectangle here. Its width is going to be 1/2. I need to find this height right there of that left side of that rectangle. So I'm going to plug a 1 into here. Square root of 1 is 1 plus 1 is 2. Guys, the reason I like to write my numbers on here, I'm now going to use those numbers over here in a second. Now, my last one, I've got 1/2. I need to find the height of this left bounded rectangle. So I'm going to plug 1.5 into my original. And when I did that earlier, I had 2.22. Now guys, we're just going to run that through a calculator. I'm going to take my 1/2 times 1 plus 1/2 times 1.71 plus 1/2 of 2 and 1/2 of 2.22. While I'm here though, I'm going to mention I could have also factored out a 1/2 here because they each have a 1/2, And then notice what I have. I have the height of the left, the first rectangle on the left, plus the height of the second rectangle, plus the height of rectangle number 3, plus the height of rectangle number 4. So there's another way that I could have wrote that. Now, guys, what you did not see is when I filled out my class examples, I do not work very hard on these. I graphed the square root of x plus 1, and I noticed that I was starting at 0, counting by a half. So in my table, I told it to start at 0 and count by 0.5s. And then I came back over to here, and I knew at 0, it's a height of 1. At 1/2, it's a height of 1.71. And then 2, 2.22. I haven't used this one yet, but here in a little bit I will. It's going to have a height of 2.41. Now, when I ran this through my calculator, you should get about 3.465. And it looks like my directions said round to the nearest hundredth, so about 3.47. Okay, so guys, there's our process. Now, I'm going to speed it up a little bit. Now let's pick on the right bounded. This is still a 0, a 0.5, a 1, a 1.5, and a 2. The heights, I know that's a 1, a 1.71, a 2, a 2.22, and I know that this one's a 2.41. Now, since we're doing right-sided rectangles, guys, this guy right here, this height won't get used because it's on the furthest left. So when I go to do this one, I know every rectangle has a height of 1/2. I need the height of rectangle number 1 on the right-hand side. Well, that height is 1.71. The next height on the right is a 2, a 2.22, and a 2.41. If you run that through your calculator, I had about 4.17. Now, these aren't perfect. If you would, look at 1A real fast. Notice that this is a low estimate. This is called an underestimate. It's under because I left out that, and that, and that, and that. 1B is going to be an overestimate. Because I added extra there, 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 and there. Now, come over to 1C, the midpoint method. Well, these are still 0, 0.5, 1, and 1.5. But now here's what the midpoint method does. Notice that my curve touches it in the middle. Well, the mid number between 0 and 0.5 is 0.25. The middle number between 0.5 and 1, if you add them together and divide by 2, that number is going to be 0.75. I'm going to do it again. That number is going to be 1.25. And if I do it again, that number is going to be 1.75. I want you to notice something here. Notice that the width of each rectangle is still 1/2. Notice that my midpoints also have a difference of 1/2. So as soon as I found the first midpoint, I could just add 0.5 to it every time. Now, how's this going to look? Well, I need to do this. The area of the first rectangle has a width of 1/2, but I need to multiply it by f of 0.25. And then I need to add to that the 1/2 times f of 0.75, because I need these heights here, plus 1/2 of f of 1.25 plus 1/2 of f of 1.75. Now, to shorten this up and make it easy on your calculator, guys, I know this is going to be 1/2. Now, instead of running 0.25 through that equation, then 0.75, then 1.25 and 1.75, let's come back to your calculator. Tell it to start at 0.25, and count by 0.5s, now let's look at your table. I know that f of 0.25 is 1.5. I know that f of 0.75 is 1.87, 2.12, and 2.32. So to find this area, it's going to look like this. F of 0.25 was 1.5 plus 1.87 plus 2.12 plus 2.32. If we run this through our calculator, I had about 3.905. So guys, I've showed you 3 of 4 methods so far. There is my left bound on my first slide. There's our left bound. There's our right bound. And then we did our midpoint. Now, I've got to show you the trapezoid. I also, before I do that, I'm going to take you back to your geometry days. Remember to get the area of a trapezoid. It's 1/2 of the height times the sum of the bases. Been a while since you've seen that formula. Remember, your bases are the 2 parallel sides. So in my trapezoid, there's base 1 and there's base 2. Here is going to be my height. This part is just there. So here goes. I'll break this down as we go. I'm still going to use the numbers that we know exist from 1a. I know this number is 1. I know that this number is 1.71. This was a 2, a 2.22, and a 2.41. So guys, once we find it for one of them, we're going to keep using it. Well, here goes my trapezoid method. The area of trapezoid number 1 is going to be 1/2 of the height, which is also 1/2. The height was 1/2 times the sum of the bases, 1 plus 1.71. Plus, now let's go get trapezoid number 2. So I'm right there. So I've got a 1/2 times the height, which is 1/2, times 1.71 plus 2. Now let's go get our third trapezoid. I've got a 1/2. The height is also 1/2. The 2 bases that I'm working with this time is the 2 and the 2.22. And then last but not least, my fourth trapezoid, 1/2 the height times the 2 parallel bases. They look a little different because normally in geometry you guys have always studied trapezoids drawn like this, where the bases looked parallel. So guys, that's what it looks like trapezoidal wise. Now, if you grab your calculator and run that through, you should get something about 3.82. The actual area, just so you can compare the 3, 4, is about 3.886. That's the actual. And I'll show you how to get to that actual in the very near future. So guys, I did all 4 types on my first example. Now I'm really going to cut that down on my next 2, just because they're so tedious and I don't want this to run into a 30-minute video. So here goes my number 2. You have to decide if it's left bound, right bound, midpoint, or trapezoids. So I'm hoping that you look at this one and you notice that they're all bounded on the left. So these we're going to do by left bound. Now, the width of my interval is 3. 0 to 3. And I'm going to cram 6 rectangles in there. So once again, 0.5. It's not always 0.5, even though it looks like it today. That number can change. So what I'm going to do down is I'm going to come down here is I know this is 0, this is 0.5, this is 1, 1.5 and 2, and 2.5. Now, Think about what we're going to be doing, guys. We need all of these heights. So let's just go get them while we're here. So I'm going to come into my calculator. Let's graph the square root of 2x squared. Maybe, let's graph that. Let's try that again. The square root of 2x squared plus 4. Notice all that's under there. I'm going to come back to my table and tell it to start at 0 again and count by 0.5s again. Now, when I go into my table, I know the height of the rectangle at x equals 0 is 2. At 0.5, it's 2.12. At 1, it's 2.45. 2.92, 3.46. So you see where I get those numbers? I'm going to write them in there, and I'm going to use them for 2a and 2b. So this height right here is 2, 2.12, 2.45, 2.92. This height is 3.46. This height is about 4.06 and 4.69. Now, think about this. I would need to add up these 6 rectangles. Well, each width is 0.5. Now, since it's left bounded, I need all the numbers starting with the far left. So I need the 2, the 2.12, the 2.45. I will not use this number. Notice I'll use 1, 2, 3, 4, 5, 6 numbers. So I need a 2 plus 2.12 plus 2.45 plus 2.92 plus 3.46 plus 4.06. Really, guys, if you look at it, there's no calculus today. When I ran that through my calculator earlier, I'm sure you'll take my word for it, I had about 8.505. Or, since I said nearest hundred earlier, about 8.51. So that was left bound. Well, let's pick on 2b then. Look at your graph and decide if it's right bound, trapezoid, or midpoint. Well, in this case, it looks like my curve touches all the rectangles on the right. So this thing will be right bounded. Well, I'm not going to work very hard. I know each rectangle width is 0.5. I need all the numbers that represent the heights from the right. So in this case, let's peek at 2a real fast. I will not use this left bounded number. I will use all of these numbers. So notice I won't be using this 2, but I'm going to have a number after the 4.06. So it looks like I'm going to have 2.12 plus 2.45 plus 2.92 plus 3.46 plus my 4.06 plus my 4.69. And if you kind of look at it, notice how these rectangles are above. I bet this one's going to be higher than the other one. It should also be higher because I'm throwing away a 2 and adding in a 4.69. And guys, when I ran that through earlier, I had about 9.85. So there's a left bound and a right bound. Now I'll do one last one because I'd like for my video to be done in about 23 minutes. So here's your number 3. Kind of an application type problem because we're going to measure distance. Suppose that an object is traveling along the x-axis in such a way that its velocity at time t is given by this equation, 1/4 t cubed plus 1 feet per second. So this curve estimates his speed. Estimate how far the object has traveled between 0 and 3. Well, I know I'm going from 0 to 3. It looks like, guys, I'm using 1, 2, 3, 4, 5, 6 rectangles. So 3 divided by 6 is 0.5. I'm going to say once again, they're not always 0.5. I think on your assignment sheet, one of them's 0.25. So this would be a 2 and a 2.5. Now, decide if this is left bound or right bound. And it looks like it's going to be right bounded. Now, let's go get all of these heights real fast. So to do that, let's type that in our calculator. So let's go y equal, let's get rid of that. Let's go 1/4 x cubed plus 1. I'm going to tell it to start at 0 and count by 0.5s, which it's doing. So there's my distances, or there's my heights that I need. The height of this rectangle is 1. The height at this point happens to be 1.03. And then we'll decide what we're using. So I'm going to scribble those in real fast. So this is 1. This looks like 1.03. This one looked like 1.25. This one looked like 1.84. And then a 3, and a 4.9, and a 7.75. So really that 4.9 and 3, so let me put them where they kind of go. Boom, boom, boom. 3 and 4.9 and 7.75. So now guys, just decide which of those numbers you want. Since we're doing this by right bound, there's my 0.5. Decide if you need the 0 or the 7.75. We need to include the right in this time, so you will not include that left one. So this 1 doesn't get included. So I need 1.03 plus 1.25 plus 1.84 plus 3 plus 4.9 plus 7.75. Now if we run all that through, you should get about 9.885, and in this case, feet. The object has traveled approximately 9.885 feet. If we can figure out that area, that tells us the distance, area under the curve. Hey, now notice though, this one definitely looks like it's a bit over. Now, let's quickly do this one. This one definitely is left bound, so I would like to include that left bounded number, that 1, and then the rest of them, I just will not include that 7.75. So it looks like we'll have this. Looks like this is going to be a little under. And when I ran that through, I had about 6.51. And then once again, my units are going to be feet. Okay? So guys, that's day 1 of Riemann sums. Take your time on the assignment. Use your calculator. It's a tedious lesson. I wrote it to be a tedious lesson, so you'll be a little more appreciative here in 2 classes. So guys, good luck. Enjoy.